Today we are going to be looking at arithmetic sequences. An arithmetic sequence is a finite set of values found by repeated addition of a common difference. And the common difference, the definition is just that it's the arithmetic change in an arithmetic sequence. So let's take a look at some examples. We want to know if the given sequence is arithmetic, and if so, what is the common difference? So if we take a look, if we go from 2 to 4, we're adding 2. Then when we go from 4 to 8, we're adding 4. And then we're adding, 8. So if we take a look, these are not a common difference, so this is not an arithmetic sequence. So now if we look, when we go from 6 to 12, we're adding 6. Then we add another, and another. So this is an arithmetic sequence because we have a common difference of a positive 6. In our last one, when we go from 2 to a negative 1, we're subtracting 3, or we're adding a negative 3. So this is an arithmetic sequence because they all are the same, they're all common, and our common difference is a negative 3. So let's take a look at some formulas. The recursive formula is where we look at our initial value, and our initial value, which is meaning the A1, is where we start. We look at this for our recursive, a sub n, which the n stands for the term that we're working with. A sub n minus 1, n still stands for that term. And the d is our common difference. In our explicit formula, we have a sub n. Remember again, n still stands for our term. A1 is where we start, the initial value, then n minus 1, and n, like we said before, is the term we're looking for, and d is still our common difference. So let's use what we know, and we want to find the 12th term of each sequence. So we right now know the 11th term is 8. So if we want to find the 12th, that means we're just looking for the next one up. And if our common difference is 5, that means we are adding 5 to 8. So our 12th term is 13. So let's take a look here. If we have the 15th term, and we know it's 30, we have a common difference of negative 4. So that means the next term, the 16th term, when we're adding a negative 4, so we'd be at 26. But we don't want the 16th term, we want the 12th. So if we take a look, the 14th term, the one previous, so the recursive, would be 34. The 13th would be 38. So then the 12th is 42. Alright, using this sequence, you want to write both the explicit and the recursive. So let's take a look back up here. We'll start with the recursive. Recursive formula is a sub n, because we don't know the term we're looking for, equals a sub n minus 1 plus our common difference. So if we're taking a look here, our common difference is that we are adding 6 each time. So here's our recursive formula. The explicit formula is using this one. So we have a sub n equals a1, which is our start, and we start at 3, plus n minus 1 times by our common difference, which is 6. We can also rewrite this, a sub n equals 3 plus 6 times n minus 1. Okay, so let's find the 51st and the 89th term of this sequence. So instead of having to figure out all of them, doing 22, 18, and keep going, let's use the explicit formula, which is a sub n equals a1 plus n minus 1 times by our common difference. So for the 51st term, that means we want the 51st term. Our first term is 22, n is 51 minus 1, and our common difference we have here, we're subtracting 4. So we're multiplying by negative 4. So if we simplify this out, 51 minus 1 is 50, times that by our negative 4. So 22, 50 times negative 4 is a negative 220. Oops, sorry, negative 200. So then 22 minus 220 is a negative 178. So let's look at finding the 89th term. Using the same formula, we want to find the 89th term. Our first term, our initial term, is still 22. But we're now looking for the 89th term, so we're subtracting 1 from that. And our common difference hasn't changed. It's still a negative 4. So if we solve this, 89 minus 1 is 88. Multiplying that by a negative 4. So when we do 88 times by a negative 4, we get a negative 352. And 22 plus a negative 352 is a negative 330. Let's flip over to the back side. You are saving money for an iPad. You already have $100. And we plan to save at least $15 a week. We want to know how much money we'll have at minimum after 18 weeks. So we know we have $100 after just 1 week. So the first term we have $115. So we're saying that we started with 0, which we're going to say A0, and after 1 week we're at 115. So to find after 18 weeks, we can still use the explicit formula. So if A equals 18, we started with 115 on our first week, plus 18 minus 1, and we have a common difference of 15. That's how much we're adding each week. So if we solve this, 18 minus 1 is 17. Multiply that by 15. 17 times by 15 is 255. So 115 plus 255 is $370. So let's look at our last concept for today. Finding the arithmetic mean. To find the arithmetic mean, we take the sum of the two numbers and divide it by 2. So if we take the sum of our two numbers and divide by 2, 84 plus 110 is 194. And we divide it by 2. The arithmetic mean is 97. So then for the next one, if we take the sum of our two numbers, 24 plus 57 is 81, and then we divide it by 2, we have the arithmetic mean of 40.2.